can hit those and wrap this up. So a little more practice, but like I said, we are staying on this for a while until I am confident that you have it, because we need it forever. So we will not move on until I feel like everybody knows what they are doing. Let's look at this one. So, like I mentioned yesterday, a lot of times it's easier to multiply things out first when we're dealing with polynomials, but the whole reason we're doing this is because sometimes we can't just multiply first. So if I gave you this problem, would you probably multiply it out? Yeah. But since we're practicing the product rule, we're not going to. Because it says f of t, that means t is the variable here. So square root is like a t to the 1/2. A and b, they're just representing constants. Okay, so whatever variable is inside your function notation, that is the variable. Any other letters are assumed to be constants right now. So if I did the product rule, how does the product rule work? Right, so we do one derivative at a time. So the derivative of t to the 1/2 would be 1/2 t to the negative 1/2 times the second one plus the first one times derivative of the second. What's the derivative of a going to be? 0. Plus, what's the derivative of bt? C. Because this is a t to the first, so when you do your derivative, the 1 comes down, so 1 times b is b, times t to the 0, anything to the 0 is 1. Alright, so if I wanted to clean this up, we can multiply, so we get 1/2 a t to the negative 1/2, or you could write that as a over 2. 1/2 b, I'm just going to go ahead and put it as b over 2. T times t to the negative 1/2. What do you do with those exponents? Add them. 1/2, negative 1/2 plus 1 is positive 1/2. Plus b t to the 1/2. Do we have any like terms? This is like a 1/2 b plus 1b, which would be a 3/2 b. T to 1/2. So probably a lot easier if we just distributed first. And after we practice this, you can. We're just using some nicer problems to learn. Okay. F of x is the square root of x, so we can write that as x to the 1/2, times some function g of x. And I don't know what that function is. I'm asking you to find f prime of 4. One big thing, when I want the derivative at a specific number, you have to do the derivative before you plug in the number. If I plug a 4 in first, then I get a constant. And what's the derivative of any constant? 0. So you have to do the derivative, then plug in your numbers. Alright, so f prime of x. Derivative of the first. What's the derivative of x to the 1/2? Times the second one. Plus the first. Times the derivative of the second one. So I don't know what g of x is. All I can say is the derivative would be g prime of x. Alright. Can I plug in things now? We want f prime of 4. So I have 1/2 x to the negative 1/2. And negative just moves it to the bottom. 1/2, that means the square root. So that's like 1 over the square root of 4. Times g of x. What is g of 4? 2. Plus x to 1/2, so the square root of 4. Times, what is g prime of 4? So, square root of 4 is 2. So 1/2 times 1/2 times 2 is 1/2. Plus 2 times 3 is 6. So we get 13 over 2, or 6.5, or 6.5. So we didn't actually know what function g was, but I gave you enough information to be able to evaluate. Is that one okay? I did example 8 yesterday, right? So we can go to 9. So we're asked to find z prime, which is the same thing as dz dt. This is a fraction. So what do we have to do? Quotient. The quotient rule is low d high. What is the derivative of the top? Minus high d low. What is the derivative of the bottom? All over low square. How many terms do we have on top? 2 main terms. Can I cancel a 1 plus t to the 4th out of this? Only if it's in both of these 2 terms. So they don't both have 1, so I can't cancel it. So we just have to start multiplying things out. So negative 3t squared minus 3t to the 6th minus, and this one if I distribute my 4t cubed, put a denominator, distribute the negative, negative 3t squared minus 4t cubed plus t to the 6th over 1 plus t to the 4th squared. And you certainly could multiply out the bottom, but I typically do not. It'll make it easier if we have to do higher derivatives to leave it as a parenthesis. Is that one okay? Take a look at this one. Think about it for a second and see if you can figure out what you would need to do. So before I jump in, I want you to try. you think? What do we have to do? We need the derivative, and to do that we have to do the quotient rule. Equation of a tangent line, the only way to get the slope of a tangent line is the derivative. So low, 1 plus x squared. D high, what's the derivative of e to the x? Minus high. D low, derivative of the bottom. Over low squared. Alright, so on the top, you can distribute that e to the x. You could factor it out since they all have it. Either way is fine. Or if you distributed, each of those terms has an e to the x with it. Alright, equation of a line, we need a point and a slope. Here's my point. How do I get my slope? I have to plug the 1 in. This is my x, so plug it into my derivative. So e to the first is e. 1 minus 2 plus 1 over 1 plus 0 squared. And what do we get? E times 0, which is 0. So y equals mx plus b. So y-intercept is 1/2 b. So our equation is y equals mx plus b, or just y equals 1/2 b. Just a horizontal line. Any questions there? Okay, so the last thing on here, this is a summary of everything we've found so far. Derivative of a constant is always 0. If you have x to a power, the power comes down, subtract 1. Derivative of e to the x is still e to the x. Coefficients just trail along. If you have things added, subtracted, multiplied, or sorry, added or subtracted, we do the individual derivatives and then add or subtract. When it's multiplication, we do product rule. Division, we do quotient rule. So we still have more that we're going to add to this, but that's where we're at right now. So you guys have that handout from yesterday. That's your top priority. So I want you to work on that first. If you get done and have time, then you can start these. And like we already decided,